Hi everybody. Today we're going to do lesson 813. Okay, and we are going to it says exploring quadratic functions. It's more of this vocab that we did yesterday, and I just want to make sure that you're hearing these words so that next year when you're in geometry, and you will hear these words, that maybe you'll remember them. All right, so as we go along, just write down the words that I'm writing down. You don't have to write down all of the notes, but if you write down the words I'm writing down, I'm just hoping that it'll sink in, okay? So, linear functions, this is what we're starting with. Linear functions have the form y equals mx plus b, okay? And make a line. So that's all you have to write is linear, y equals mx plus b, line, and then you can just draw a little line if you want. Okay, next one we're going to talk about is exponential functions. Okay, exponential functions have the form, do you guys remember what this one is? It's y equals a times b raised to the x. So exponential is when the exponent is an x, and it makes a curve. We call it a curve. So it looks something like this. This would be exponential growth. Okay, third one is what we're talking about now, quadratic equations. Okay, so quadratic equations, or quadratic functions, sorry, have the form y equals ax squared plus bx plus c, and makes a parabola. Parabola. Also known as a parabola. No, not really. Okay, so now, what would we do to graph this thing, this parabola? So let's see. It says let's graph y equals x squared. Well, I'm saying, how do we graph this parabola? How do I even know it's a parabola? That x is raised to the second power. That's a quadratic function. Quadratic functions will be a parabola. Okay, doesn't matter what else is going on as long as you have x squared as your highest exponent, only exponent. Okay, here we go. So you would put this in your calculator, y equals, and then you'd put x squared in. Then you would get a table, which is second graph, I should say. And I'm going to fill the table in. So where do we start? Well, we kind of want to be around the middle here, or somewhere on the graph paper anyway. Well, I happen to know by looking at my calculator. There's -3 gives you a 9, okay? -4 would give you a 16. That would be off the grid. So, all right, literally. All right, so -2 gives you a 4, -1 gives you a 1, 0 gives you a 0, 1 gives 1, 2 gives 4, 3 gives 9. Quite honestly, it's easier to do this by hand than in the calculator. It's such an easy expression or equation. All right, so quickly I'm going to 1, 2, 3. I'm going to plot these points. Whoops, that's 2. I gotta fix that. 1, 2, 3. Okay. 3, 9. I mean -3, 9. So there's 3, 9. We have -2, 4. That means we have a +2, 4. We have a 1, 1, and we have a -1, 1. -1, 1, +1, 1. And then we have 0, 0 right in the middle there. Try to make this as neat as I can. All right, so if you could just sketch something like that, okay? You don't have to draw the points and all that. Just sketch a parabola. Okay, now, draw a line down the middle of your parabola. In my case, this is my line right here. Oh, I'm going to use yellow. I think yellow showed up better. That's the axis of symmetry, okay? The line down the middle of the parabola is called the axis of symmetry. Okay? It means the line of symmetry. So axis means the line. For this parabola, the equation would be, well, let's start with this. It's a line, so it has to be either y equals mx plus b, or in the case of a vertical line, it's x equals. Remember Vux? VUX. So x equals, and in this case, x equals 0. Okay, that's the x value of every point on that yellow line. Okay, next, the turning point. Let's see. Hey, maybe I'll use black for the turning point. There's the turning point. It's really called a vertex. Okay, it is the max or highest point, or it's the min, the lowest point of the function. So the coordinates of the vertex of this parabola are 0, 0. Okay, that's because it's at the origin. Will it always be 0, 0? No. But for this one it is. All right, so when A is positive, the parabola's end behavior is, well, what does that mean? Well, this equation is y equals x raised to the second power. Well, there is an A value in there. Remember, there's a 1. Is 1 positive or negative? Well, 1's positive. So it says when A is positive, the parabola's end behavior is, it's called concave up. Concave up. And what it means is it kind of makes a smile. Okay, so the parabola goes upward, which means that the vertex is a minimum or min because it's the lowest point on the graph. So the vertex here is the lowest point on the graph. Okay, now when A is negative, so if my equation had read y equals negative x squared, that would tell us that we were going to have something where the end behavior is concave down. It just means the arrows are going down, like a frown. All right, so positive is up and gives you a smile. Negative is down and gives you a frown. It should be easy to remember. And the turning point, the vertex, which is the turning point, is a, well, here, look, wouldn't it be at the top of the mountain here instead of at the bottom of the valley? It's at the top of the mountain, so it's going to be the max or highest point. Okay? All right, let's keep going here. Going to get to the end of this sheet. All right. This parabola has a blank A value. So we already talked about this. It has a positive A value. So its end behavior is concave up. And its vertex is a minimum point. Okay. The blank is where the parabola crosses the y-axis. So let's think about this. The blank is where the graph crosses the y-axis. Isn't that it's true for any graph that crosses the sorry, let me say that again. Any graph that crosses the y-axis has what we call a y-intercept, and the parabola is no different. That's what I was trying to say. Intercept. So the y-intercept is where the parabola crosses the y-axis. This parabola has a y-intercept of 0. Okay, in the equation, this is it's called the C value. Wow, I'm losing it. C value, or the constant. The blank of a parabola are where it crosses the x-axis. Okay, this is called the roots or the zeros. You'll see, we'll go back and forth, but we're going to call them roots for now. The roots of the parabola are where it crosses the x-axis, just like the x value of the point. So a parabola can have 0 real roots, 1 real root, or 2 real roots. So it's just saying how many times does the parabola touch the x-axis. In this parabola, it crosses the x-axis 1 time. And by crosses, I mean it runs into the x-axis 1 time. And so it has 1 root. And that root is, I'm going to go back up to our graph, What's the x value of this point here? It's 0, right? So that's our root. All right, that's it. 10 minutes, 2 seconds. I'm done. Hope you have a great day. Write all this down. Put it in through Google Classroom if you can. It's much easier for me to keep track. If not, you can put it through email, but I'd rather Google Classroom, please. Thank you. Okay, bye. Have a good day.